So the first step in these types of questions is we have to consolidate these log terms. And you'll see the base is x minus 3 in both of these terms. So if I bring that term to the other side, I can combine these two and do the division and then go back to the exponent form. Now, a couple things to keep in mind is that that base, it can't be negative or 0. So that's going to remove some constraints here. But what I'm going to do is to do that at the very end. This is our difference of squares identity. And then not divide by any terms. So factor out x minus 3. So x plus 3 over x plus 1 minus x minus 3 equal to 0. That becomes x plus 3 minus, and then I have to multiply those two out. So x squared minus 3x plus x minus 3, and I have still that minus sign to deal with, over x plus 1 equal to 0. So I'll simplify that first. X squared, and that's minus 2x, so that will become 2x, and then plus 3. So that whole thing would simplify to minus x squared plus 3x plus 6 equal to 0, over x plus 1 equal to 0. Now, in terms of, for this expression to be equal to 0, x could be 3, but note that would mean the base is 0, so this is not a possible value for x. If we look at that quadratic, and I'm just multiplying this by minus, there are two roots here. So I'll write those two roots as using the quadratic formula, 3 plus minus 3 squared 9 minus 4 times minus 6 over 2. So that's 24 plus 9, 33. So these are my two roots. Now the question is, are they both acceptable? Because if you were to just add these two, then you'll see that the sum is 3, and of course that's here as well, but you have to kind of question. Now this number is negative. Square root of 33 is about between 5 and 6, so that number is negative, and you're subtracting 3 from it, so you get a negative base, and logs are not defined for negative base. So this is also not acceptable. That's why I think that's the trap answer. And that means this is the only acceptable value. And so the sum of all possible real values of x is just that, which is choice D.